Welcome to tonight's video on topic 2, exponents and radicals. Just a couple of rules here to remember that when you're multiplying things with the same base, you add the exponents, right? You raise an exponent to a power and you multiply. And then when you divide the exponents, you subtract them. But remember, it has to have the same base. So here, if I raise a fraction to a power, remember that means I can make it a to the m over b to the m. And if I raise two terms, a product to a power, then you can distribute the exponent to both of them, but it has to be a product. And then anything to the 0 power is 1. And remember, if a to the m equals a to the n, then that means that the exponents are the same, that m equals n. And when it's a negative exponent, it's the same as the reciprocal, 1 over a to the n. So here, we would take negative 3 to the third, x to the fourth, so you multiply, gives you x to the 12th. Y to the fifth to the third gives you y to the 15th. And negative 3 to the third gives you negative 27. Remember, with fractions here, I would divide the numbers. So negative 35 over 5 becomes negative 7. 2 minus 6 becomes negative 4 for x, the exponent. 4 minus negative 8 means it's y to the 12th. And then any negative exponent, you're going to move to the bottom of the fraction. So it becomes negative 7 over y to the 12th, x to the 4th. Here, I would simplify in the parentheses first. So simplify in the parentheses first, and then raise everything to the negative third power. So since this is already simplified, I can then raise it to the negative third power. So that becomes y to the third on the top, and then 4 to the third and x to the sixth go to the bottom, and then 4 to the third becomes 64. All right. Now here, before I can multiply these, I have to raise that to the third power. So it becomes 3 to the third, x to the third, y to the sixth. And then I can multiply the like terms. Well, 3 to the third is 27. X to the third times x to the third. Remember, when you multiply, you add the exponents. And y to the sixth times y to the fourth gives me y to the 10th. Here in the parentheses, I'm going to simplify, so I get negative 3. And then 4 minus 10 gives me a to the negative 6th. 2 minus a negative 3 gives me b to the 5th. And then that's raised to the negative 2nd. So remember, if I'm raising it to the negative 2nd, that means it's 1 over this to the second power. So basically, you have 1 over negative 3 squared, which is 9. A to the negative 6 squared, so you multiply the exponents, a to the negative 12th. And then b to the 5th squared gives you b to the 10th. So now the a to the negative 12th goes to the top of the fraction. And you get your final answer. All right, so this one here, I have to square this first, so it becomes 2 squared, x to the negative 6th, y squared z to the negative 12th. That's one parenthesis, and then the next parenthesis, I have 2 to the negative 5th, x to the negative 5th. So now I multiply the like terms. Well, remember, I add the exponent, so this is 2 to the negative third. Negative 6 plus negative 5 is negative 11. And and then you have y squared z to the negative 12th. So remember, bottom of the fraction go all the negative exponents. So 2 to the 3rd is 8, x to the 11th, z to the 12th. Final answer. All right, so scientific notation. Scientific notation is when a number, a decimal or a large number is written as a number times the power of 10, where the number is either between 1 and 10 or negative 10 and negative 1. And n is an integer, meaning it can be a positive or negative whole number, right? So if you have, and you're raising it to a positive power, that means the number is going to get bigger. And if you're raising it to a negative power, that means the number is going to get smaller. So for example, here to convert to scientific notation, you start where the decimal would be, and then you just move backward 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now it's 3.497 times, and we basically moved 10 spaces, so it'd be times 10 to the 10th because we went to the left. So here we have a negative exponent, or negative, we have a decimal, so we're going to have a negative exponent. We're going to 1, 2, 3, 4, 5, 6, 7. To go to decimal notation, two, three, 4. So it becomes negative 0.00031. And since it's positive here, you're going to go to the right. So you have 2.34, and you go 1, 2, 3, 4, 5, and just fill in with zeros. So you have 234,000. When you multiply with scientific notation, multiply the numbers first. So 6.1 times 4 is 24.4. Then multiply the exponents next. Well, 5 plus negative 9 is negative 4. Now, this is not in scientific notation. You have to move it, so make it 2.44 because it has to be between 1 and 10. And when you make this number smaller, you're going to make the power bigger. So it's going to become 10 to the negative 3rd. Um, 1.8 divided by 3 times 10 to the 4 minus negative 2 is 10 to the 6th. 1.8 divided by 3, really quick, gives you 0.6. So this is 0.6. Hold on 1 second. We lost it. There we go. Sorry, lost the pen a little bit here. All right, so 0.6 times 10 to the 6th. So now to make it in scientific notation, we have to make it 6.0. And since we made this bigger, we have to make that smaller. So it's 10 to the 5th. And then here, when you divide, what I would do is I'd change it into scientific notation first. So I would make this So I'd make this, it goes 3, 6, 9, 10, 11. So I'd make it 4.8 times 10 to the 11th. Over. And then this one, when I move it this way, it's going to be 1.2. But then when I count, I moved it 1, 2, 3, 4 spaces. So it's going to be 10 to the negative 4th, because it's a decimal to begin with. So then when you divide, 4.8 divided by 1.2 is 4. And then you subtract the exponent, so you get times 10 to the 15th. So here you would multiply this first, but let's do it in scientific notation. So we have 1, 2, 3, 4, so 7.2 times 10 to the 4th. And then times 1, 2, 3, so 3 times 10 to the negative 3rd. And then this would be 1, 2, 3, 4, 2.4 times 10 to the negative 4th. So now we can multiply. So 7.2 times 3 gives you 21.6 times 10 to the 1st, right? And then here it gives you, and then 2.4 times 10 to the negative 4th. And then when we divide 21.6 divided by 2.4, you get 9. And then 1 minus negative 4 gives you 10 to the 5th. All right, talking about radicals and how to do square roots, cube roots, simplify with variables. One of the rules is when you take an even root of a number, b must be positive, right? When you take an even root of a number, it has to be positive, and the result must be positive. When you take an odd root of a number, b can be positive or negative, and the result can be positive or negative. So for example, the cube root of 8 is 2. The cube root of negative 40, well, remember, perfect cubes, right? Numbers that are perfect cubes, 1, 8, because 2 to the 3rd is 8, 27, 64, 125, right? Perfect squares, it's 1, 4, 2 squared, 9, 16, 25, 36, 64, 81, 100. Those are the ones up to 10. So for perfect cubes, this is the cube root of negative 8 times 5. And the cube root of negative 8 is negative 2. And then you're left with the cube root of 5 inside. The square root of 500, well, the highest perfect square that goes into 100 is, or 500 is 100. And then the square root of 100 is 10, and the square root of 5 stays in. The square root of negative 49 is not a real number because you cannot take the square root of a negative number. Now, when you deal with radicals, basically the rule is, like if you have the square root of x to the fourth, this is the second root of x to the fourth. You divide these two, and that gives you the square root of, that gives you x squared. So here you have the square root of 8 times the square root of x to the fifth. The square root of 8 is 2 rad 2. The square root of x to the fifth, well, 2 goes into 5 twice, so it's going to be x squared, and then there's going to be 1x left over. So it's going to be 2x squared, square root 2x. Here, the fourth root of 16 times the fourth root of x to the fourth. Well, the fourth root of 16 is 4, or is 2, sorry. And then 4 goes into 4 once, so it's x. Now, there is a rule when you deal with radicals that says if, and it's up here, if it's an even root of an even power and it comes out odd, then you got to put absolute value, and that's what happened here. You had an even root, even power, right? And it became an odd power, so therefore you put the absolute value. Cube root of 125 is 5. The square root of 27 times the square root of x to the sixth. Well, the square root of 27 is 9 times 3, so it's 3 square root 3. And then 3 goes into 6 twice, so there's no absolute value because it's even, even, even. So it becomes 3x squared, square root 3.